Good day, grade 9. In this video, we're going to solve sample problems on the topics 0, negative and rational exponents, radicals, and application of radicals. For question number 1, what is the simplified form of 4 raised to 0 times 5 raised to negative 2 times 6 raised to negative 1 times 100 raised to 0 times quantity 1 over 2 raised to negative 1. Based on the laws of exponents, any number raised to 0 is equal to 1. And any number raised to a negative exponent, say x raised to negative n, is equal to its reciprocal raised to the positive exponent. So using these concepts, we could simplify 4 raised to 0 multiplied by 5 raised to negative 2 times 6 raised to negative 1 times 100 raised to 0 times 1 over 2 raised to negative 1 as consider 4 raised to 0 as 1. So we have to rewrite 1. Then consider 5 raised to negative 2 here as 1 over 5 squared, and 6 raised to negative 1 is 1 over 6 raised to 1, and 100 raised to 0 is 1, while 1 over 2 raised to negative 1, since the denominator has a negative exponent, then you can just make it as a numerator with a positive exponent. So that's 2 raised to positive 1. So simplifying, we can just cancel out 1. So 1 over 5 squared is 1 over 25 multiplied by 1 over 6 raised to 1, or simply 1 over 6 multiplied by 1. We can just cancel out 1 multiplied by 2 raised to 1, or simply write 2. So this is 1 times 1 times 2, that's 2, all over 25 times 6, that is 150. And since this 2 over 150 is a fraction whose common factor on the numerator and denominator is 2, so you can simplify this fraction by dividing both the numerator and the denominator by the common factor, which is 2, and you get 1 over 75. So that's the simplified form. Now let's move on to this next question. What is the equivalent of cube root of 4 plus fifth root of 2 using exponential notation? Before we transform these radicals into their exponential notations, let me show you the proof of transforming radical expression into exponential notation. So let's say we have the nth root of x raised to m is equal to x raised to a, and x raised to m, or nth root of x raised to m, is to be raised by the inverse of nth root, which is n. Also, we raise x raised to a with n. So since the inverse of n is the nth root, so they cancel each other out. We have x raised to m is equal to x raised to a to the power of n. By using or applying power of a power, you have x raised to a n. And since they have the same bases, these two expressions of the same bases, it's obvious that their exponents are equal. So we have m is equal to a n. Now solving for a, we have to eliminate or divide all sides by n. We have a is equal to m over n. Going back to our equation, therefore, since a is m over n, we have x raised to m over n. So therefore, we have shown that the nth root of x raised to m is equal to x raised to m n. And notice the changes in our expression. The index of the radical expression will become the denominator in the fractional exponent, while the exponent of the radicand will become the numerator in the fractional exponent. So therefore, going back to our question, we simplify or we express the cube root of 4 plus fifth root of 2. Then we have the 4 raised to, there is an understood exponent of 4 here, which is 1. So 4 raised to 1/3 plus 2 raised to 1/5. There is also an understood 1 here. That's why we have 1 as the numerator of the fractional exponent. So this is 4 raised to 1/3 plus 2 raised to 1/5. And that's it. Next question. What are the solutions of the square root of 2x minus 3 equals x minus 3? So we are going to find the solutions of this radical equation here. So we have to rewrite first 2x minus 3 equals x minus 3. And we have to get rid or eliminate the radical sign here, the square root sign, this one, by raising the whole equation with the inverse of the square root. Since the inverse of the square root is an exponent 2, then we have to raise both sides of the equation by an exponent 2. This is 3. So you have eliminated the radical sign now and the exponent. You get on the left side is 2x minus 3, and on the right side we have x minus 3 multiplied by another x minus 3. And simplifying, this binomial multiplied by another binomial is to be expanded. So x times x, we have x squared, then outer minus 3x, then inner terms, another minus 3x, then last terms, so plus 9. And on the left side, you have 2x minus 3. Now we simplify by combining similar terms. So just rewrite the quadratic term, x squared. But we have negative 3x minus 3x as similar terms. So that's 6x to be joined by another term similar to it. This one, 2x. So it will become negative 2x now. Since we transpose it to the other side of the equation here, so its sign becomes negative. Then this negative 3 will be transposed also to the other side of the equation here. So just rewrite 9 and the 3 becomes positive. 0 on the left side. So x squared minus 2, that's 8x plus 12. Then by factoring, you can solve for the solutions of this quadratic equation. So by factoring, you have to think of two numbers that if you multiply them, the result is 12. And if you add those two numbers, the result is negative 8. And that is negative 6 and negative 2. So the factors of this quadratic equation are x minus 6 and multiplied by x minus 2. By applying zero product property, you have to equate each factor to 0. So the first factor is x minus 6. So we have to equate it into 0. And solving for x, you transpose 6 to the other side. You get x equals 6. So that's the first solution. And the other solution comes from the second factor, x minus 2 equals 0. Transpose negative 2 again to the other side, you get x equals positive 2. So this is the other solution. The two solutions are 6 and 2. Well, we can check if our solutions are real or extraneous. So by simply substituting the solutions that we have solved to this original equation. Okay, so first we substitute the first solution on this equation. So we have to plug in x with 6. So 2x becomes 2 times 6 minus 3 equals square root of 2 times 6 minus 3 equals 6 minus 3. So it's still a question mark. But 2 times 6 is 12. 12 here minus 3, that's 9. So square root of 9 equals, on the other side, we have 6 minus 3, so that's 3. But the square root of 9 is 3, so that's 3 equals 3. And we have proven it right. So that's one solution. 6 is a real solution. The other one, the other solution that we have solved, which is 2. Again, plug in 2 to the equation. So we have 2 times 2 minus 3 equals 2 minus 3. We have 4 minus 3 here is 1 equals 2 minus 3, that's negative 1. But the square root of 1 is 1, while the negative 1 is the other side. So they are not equal. Therefore, this 2 here is not the real solution or the real root, but it's called the extraneous root. Let's have this next question. What is the result after simplifying 2 square root of 3 plus 4 square root of 3 minus 5 square root of 3? In addition and subtraction of radicals, the radical parts should be similar, meaning they have the same indices and they have the same radicals. So the radicals here are all square root of 3. So we can go ahead and just add the numerical coefficients of these radicals. So you have 2 plus 4, which is 6, minus 5, and that is 1. So 1 is square root of, just rewrite the common radical, which is 3. Or simply, the answer is square root of 3. Next question. What is the result when we simplify quantity 2 square root of 8 plus 3 square root of 5 times quantity 6 square root of 8 plus 7 square root of 5? So since we multiply two groupings or two parentheses, we have to rewrite them first. That's 8 plus 7 square root of 5. Then applying the first outer inner last method or FOIL method, you have to multiply the first terms. But 2 times 6 for the coefficients are or is 12. Then 8 times 8 for the radical. 8 times 8 is 64. Then for the outer terms, we get 2 times 7, that's 14. And for the radical, that's 8 times 5, that's 40. Then plus, we get 3 times 6, that's 18. And 5 here times 8, that's 40. Then for the last terms here, we have 3 times 7, and that is 21. And 5 times 5 here, and this one, that's 25. Now we simplify 12 times the square root of 64, which is the square root of 64 is 8. We just simply write 8. Then 14 plus square root of 40. The radicand 40 has a factor which is perfect square. So we have to break down 40 such that one of its factors is a perfect square, and that is 4. So we express 40 as 4 times 10, then 18 is also 4 times 10, then plus 21 here plus times square root of 25, but the square root of 25 is 5. So we just simplify it as 5. Then simplifying 12 times 8, that's 9. 96 plus, on this part, we have to extract now the square root of one of the factors, which is 4. So we bring it out as the square root of 4 or 2. Then the factor that will remain inside is 10 plus 18. Then another, this 4, should be written outside as 2. Then 10 plus 21 here multiplied by 5. That's 105. Then combining similar terms, the terms without the radical are 96 and 105 is 201 plus the terms with radicals. First, this is 4 times 2, 14 times 2, that's 28 square root of 10 plus 18 times 2, that's 36. So we have, again, rewrite 201 plus, now since 28 is square root of 10 and 36 is square root of 10 are similar, then you just have to add the numerical coefficients 28 and 36, which is 64. Then just attach the common radical, the square root of 10. Therefore, this is the simplified form or result of our operation. 201 plus 64 square root of 10. Now let's move on to this next question. What is the result when we simplify 6 minus the square root of 2 all over 4 minus 3 square root of 2? So let's rewrite 6 minus the square root of 2 all over 4 minus 3 square root of 2. To simplify this, since the denominator involves radicals, we rationalize them. So in rationalizing expressions with subtraction or addition as its operation, then we have to multiply conjugates. Conjugates are expressions or radical expressions that if we multiply them, they will result to certain rational expressions. So the conjugate of 4 minus 3, the square root of 2 is 4 plus 3, the square root of 2. Then just copy on the numerator, that's 4 plus 3, the square root of 2. So let's multiply first the denominators. Then we apply FOIL method again because this expression is a binomial and the other expression, this expression is also a binomial. So first terms, that's 4 times 4 is 16. Then outer terms, that's 4 times 3 square root of 2, that's positive 12. square root of 2. For the inner terms, we get negative 3 square root of 2 times 4. So that's negative 12 times square root of 2. And for the last terms, we get negative, that's 3 times 3. The other 3 is negative, so negative 9. Negative 9 and 2 times 2 is square root of 4. And for the numerator, we have to do the same FOIL method. First outer, inner, last method. So we have 6 times 4, that's 24. Then 6 times 3, square root of 2, that's 18, square root of 2. For the inner terms, we have 2 times, or square root of 2 times 4. So that is negative 4 square root of 2. And for the last terms, we have 3 or square root of 2 times 3 square root of 2. So you have negative 3 and 2 times 2 in the radicands is 4. Now simplify the denominator. So we have 16 here, while 12 plus the square root of 2 minus 12 square root of 2 is 0. So you can cancel this out now. Minus 9 times 4, or 9 times the square root of 4 is 9 times the square root of 4 is 2. So 9 times 2. And in the numerator, we have 24 plus this 18 square root of 2 minus 4 square root of 2 are similar radicals. So we can just have to subtract their coefficients. We get 14 because 18 minus 4 is 14, and attach the common radical, which is square root of 2, minus here we have 3, and the square root of 4 is 2. Then simplify. In the denominator, we have 16 here times minus 9 times 2 is 18. And on the numerator, we have 24. And this 3 times 2 here is 6. So minus 6 plus 14 the square root of 2. But 24 minus 6 can be simplified as 18. So 18 plus 14 square root of 2 all over 16 here minus 18 is negative 2. And since these terms have common factor, which is 2, I mean this 18, yeah, this 14 square root of 2, and this negative 2 can all be divided by negative 2. So if we divide 18 by negative 2, we have a result of negative 9. And if we divide 14 here by negative 2, the result is negative 7 square root of 2. And negative 2 divided by negative 2 is 1. So our answer is simply negative 9 minus 7 square root of 2. Now let's move on to our next question. What is the simplified form of square root of 3 over cube root of 3? So square root of 3 and cube root of 3 have different indices. The index here on the numerator is 2, while the index in the denominator is 3. So you cannot carry on with the operation yet because they don't have the same indices. So to transform them into common radicals or radicals with the same index, then first we have to find the LCD of these 2 and 3 as the index if we transform them into fractional exponents. So square root means raised to 1 half, so that's 3 raised to 1 half, and cube root of 3, that's 3 raised to 1 third. Since the exponents are fractions, they are 1 half and 1 third, then transform these two into similar fractions by finding their least common denominator. But the least common denominators or denominator is 6. Now transform 1 half such that the new denominator is 6. So that's 3 over 6. Or you can simply divide 6 by 2, and that is 3, then multiply it to 1. So 3 times 1, so that's 3 here. Next, 6 divided by 3 here. 6 divided by 3 is 2. Then multiply it to the numerator 1. So 2 times 1 is 2. Going back to our expressions or operation 3 raised to 1 half, that is now 3 raised to 3 over 6. And 3 raised to 1 third, that is now 3 raised to 2 over 6. Since they have the common denominator now, that is their index in our new radical expressions. So we can have 3 raised to 3 now. The numerator here becomes the exponent, and the denominator in this fractional exponent becomes the index. All over, we can nest them both inside the same radical. So we have 3 raised to 2 or 3 squared. But since they have the same base, according to the laws of exponents, if you divide numbers of the same base, you just have to subtract their exponents. So that's 3 raised to 3 minus 2. Or in short, that's 6 root of 3 raised to 1, or simply 3. And that's the answer. For the next question, Alvin walks 5 kilometers due east and 8 kilometers due north. How far is he from the starting point? So remember that in labeling the directions, so this is going to north and this is to east on the right side, and the opposite of north is south, the opposite of east is west. Now If Alvin walks 5 kilometers due east, then we have to draw a diagram going east, which is 5 kilometers. Then he turns 8 kilometers due north. Another arrow going north, which is 8 kilometers. 8 kilometers. Then if he is from here, from his starting point, and he is now here on his terminal point, how far is he now from the starting point? So we're talking about this. So let's just label it as D. And since, as you can see, we have formed a right triangle, which is the right angle is here. The opposite of this right angle is D, this one. So therefore, D is the hypotenuse. And the legs of this right triangle are 5 kilometers and 8 kilometers. Now, to solve for the unknown side of a right triangle, we will use the Pythagorean theorem. So, by Pythagorean theorem, which is has a formula of a squared plus b squared equals c squared, but a here is 5 kilometers. Let's just substitute a with 5. So 5 kilometers plus b is 8 kilometers. So 8 squared equals c, but c is the distance from Alvin's initial point to his terminal point, D. Now, 5 squared is 5 times 5 is equal to 25 plus 8 squared is 8 times 8, which is 64, equals D squared. But 25 plus 64 can be simplified as 89 equals D squared. Now, eliminating the square of D, so we have to extract each side an by an square root, because square root is the opposite of squares. So we have to extract D squared by a square root, so that they will cancel each other, the square and the square root. Also, the square root of 89 doesn't have an integral result, so let's just express it as square root of 89. Square root of 89 kilometers. For the next question, find the length of the edge of a cube whose surface area is 72 square meters. So let's draw a typical figure of a cube. Then, since the sides of a cube are all the same, we will just have to label them with S. The height for S and the length and width for S. Now, there are 6 faces of a cube. One for the top and one for the bottom, one for the left, one for the right, and one on front and one at the back. So there are 6 faces of a cube. Therefore, the surface area SA of a cube is the sum of those 6 faces. And each face is a square. So that's surface area is equal to 6 times the area of each face, which is S squared. But the surface area is 72 square meters. And it's 6 S squared. So we have to get or leave S squared alone by dividing all sides by its coefficient, which is 6. So divide this by 6 and divide this also by 6. So cancel this out. We have now 72 here divided by 6, and that is 12. So S squared is equal to 12. And to find the length of the edge of this cube, then let's just extract the square root of both sides. So S squared here, square root of S squared, and square root of 12. You can cancel this square and radical out now. So we have S is equal to square root of 12. But 12 has a factor which is a perfect square. So we have to break down 12 in such a way that one of the factors is a perfect square, and that is 4. So 4 times 3, that is 12. But 4 has a square root, and that is 2. So bring out to 4 as 2 now. So 2 is square root of 3. And since it is the length of a side, and the unit of the length of a side is meter. So each side or the edge has a length of 2 square root of 3 meters. Now let's move on to this next question. The giant swing completes a period in about 15 seconds. Approximately how long is the pendulum's arm? Using the formula T equals 2 pi square root of L over 32, where L is the length of the pendulum and T is the amount of time. Now let's draw a typical figure of pendulum. So pendulum has a string which is attached to a certain weight, which makes it suspended, and it swings on its way until it reaches this point. So if this swing or this pendulum is a swing, then it has a general formula T equals 2 pi square root of L over 32. So let's substitute. T is 15 seconds equals 2 pi times square root of L over 32. Now let's slowly leave this L here alone, being the length of the pendulum. So first we have to eliminate the square root by squaring both sides of the equation. So square the left side and square the right side. So we get 15 squared, that's 225, equals the square of 2 is 4, while the square of pi is pi squared. The square of a square root is just cancel it out. So we have just left L over 32. Now manipulate this equation so that we can leave now the L or the length alone. So you just have to cross multiply 32 to the other side and divide also 4 pi squared into the other side. So you have 225 times 32 all over 4 pi squared is equal to the length L. Then there are factors which are common on the numerator and denominator. There is 32 and 4 can both be divided by 4. So we can cancel or we can divide both 32 and 4 by 4. So 32 divided by 4 is 8 and 4 divided by 4 is 1. We may not write 1 anymore. So we have 225 times 8 here. So that's 4, 34, 16. 2 times 8, 16 plus 4, that's 20. And carry 2. 2 times 8, 16 plus 2, that's 18. All over pi squared is equal to the length. So therefore, our L or the length of our pendulum is 1800 divided by pi squared, which is approximately 182.38 feet. Now let's move on to this next question. A taut rope starting from the top of a flagpole and tied to the ground is 15 meters long. If the pole is 7 meters high, how far is the rope from the base of the flagpole? So if there's a flagpole, let's have the figure first. And from the flagpole, from the top of the flagpole, there's a taut rope which is 15 meters long, and the flagpole is 7 meters high. Then how far is the rope tied from here to the base of the flagpole? Let's say the flagpole is, or the base is here. So let's say this is D, or the distance from the base of the flagpole to the point where the rope is tied here. So since we have formed a figure of a right triangle here, where the sides of this right triangle is the flagpole, the distance from the base to the point where the rope is tied and the rope itself, then we can solve the unknown part of this right triangle by Pythagorean theorem. So from Pythagorean theorem, by Pythagorean theorem, which is a squared plus b squared equals c squared. Then a is to be represented by, or to be substituted by 7 plus d squared equals, and the hypotenuse is 15. So 15 squared, or 7 squared here. But 7 squared is 49 plus d squared equals 15 squared is 225. So we have to leave d squared alone by transposing 49 to the other side of the equation. We have 225 minus 49, and d squared is 225 minus 49 is equal to 176. But 176 equals d squared should be simplified by extracting the square root of both sides. So we can eliminate the square of d. So cancel this out and this. So you have d is equal to the square root of 176. But 176 is not a perfect square, so it doesn't have an integral root. But we can factor 176 such that one of the factors is a perfect square, and that is 16 times 11. So the square root of 16 should be brought out now as 4, and square root of 11. The unit of length we use in this problem is meters. So the distance between the flagpole and the rope is 4 square root of 11 meters. This is the answer. Now let's move on to this next question. The volume V of a cylinder is represented by V equals pi r squared h, where r is the radius of the base and h is the height of the cylinder. If the volume of the cylinder is 120 cubic meters and the height is 5 meters, what is the radius of the base? Now let's draw the figure of a cylinder where its bases are circles. And it has a radius. Let's say that is its r, and its height is h. Now, since the volume of this cylinder is given as the area of its base pi r squared times height, and its volume is 120 cubic meters, and its radius is unknown, while its height is 120 cubic meters. Or its height is, sorry, 5 meters. So to solve for r squared, we have to leave it alone little by little. But first, we should divide the two sides of the equation by the coefficient of r squared, which is, in this case, that's 5 pi. So divide all sides by 5 pi. So cancel this out. Also cancel 5 here. So we have 120 divided by 5 pi is equal to r squared. But you can divide 120 by 5, and that is 24. So 24 over pi is equal to r squared. Now we only need r. We do not need r squared. So we have to extract the square root of both sides. Extract the square root of r squared to eliminate square. So we should also extract the square root of 24 over pi to cancel the square and the square root sign. So r now equals the square root of 24 over pi, which is approximately 2.76. The unit of our volume is in cubic meters, so its dimensions is in meters. 2.76 meters is the answer.